So population grows according to an exponential growth model, and they tell us that the initial value when x is 0 is 90, and when x is 1 is 162. Now they told us that it's exponential, so we know we're multiplying to get from one term to the next. The recursive formula here tells us that to get to a term, we're going to take the previous term and times it by some number. To figure out that number, we need to figure out what we multiplied 90 by. What did we multiply 90 by in order to get 162? Well, that's not too hard to find, even though it is a fraction. All we have to do is divide both sides by 90 to get that question mark by itself. And we'll have our answer for what our common ratio is. So 162 divided by 90 is 1.8. That's our common ratio that we're repetitively multiplying by. So to write an explicit formula, we're going to have 1.8 is what we're repetitively multiplying by. That's what's going to be raised to a power. And we have a choice here. We could either write 90 here and then do an n minus 1. Sorry, no, we have a 0th case. There wouldn't be an n minus 1. The first term, when n is 0, the value needs to be 90. 1.8 to the 0 power is 1. 1 times 90 will give me the answer of 90. If I wanted to write this with the 162 in there, that would work if I write a minus 1 on that. That way, when n is 1, 1 minus 1 is 0 for this exponent up here. 1.8 to the 0 power is 1, and 1 times 162 would give me 162. But I'm thinking we probably want to go with the simplest version. The simplest version is that when n is 0, we get 90. So my explicit formula has what it is that I'm repetitively multiplying by. 1.8 is the common ratio. That's what gets raised to this power right here. 90 is the initial value when n is 0. If it wasn't that, if it was 1 and 90 or something like that, then I'd have to minus 1 off this to make it be an exponent that's worth 0. But this one doesn't have that.